Alright, this is where we left off in the last class. In the last class, I introduced ER diagram. In the last class, I started the discussion of logical design of database system. In this part, in the last class, I introduced ER diagram and the ER diagram, as well as DFD diagram. And after them, I introduced this REA process. This is the model we will rely on to build the database system. Resource, events, and engines model. Well, in this class, I'm going to introduce a 9-step process. A 9-step process modeling to implement this REA model to a usable database system. But before that, we still have some left over from the last class. First, business process versus information process. It is important to distinguish business events and information process. Well, the key distinction to note is that the business process creates information, while the information process simply records, updates, or extracts existing information. For example, a credit sale to a customer. This is a business process, but the act of actually recording information about the sale and generating a sales invoice is simply an information process. So consequently, the credit sale business process compromises a significant event which is depicted in the EER model and will eventually becomes its own table in the database. Whereas the generate invoice information process is not a, is not a significant event and will not become its own table in the database system. Of course, it is important and necessary to keep track of information process as they occur. But such information is tracked in tables of related events, such as the sales table or the shipping table. Identification of key business events and event resource and engines will be done using the ER modeling. So identification of the needed information process is done using DFD model. So first of all, let's see how to use ER diagram to model the business process. Well, we just discussed the EER model earlier in this chapter, and again, it is used to identify events, resource, and engines. Well, the first step is to identify key business events. After having identified significant events, the next step is to identify the resources involved in the business events. Next, it's necessary to identify the engines involved with business events. And the engines may be internal or external to the company. Events, resource, and engines are depicted using the entity symbol in the EER diagram. Then it is necessary to identify exactly how the resource entities and engines entities and related to the events identified. And the events will typically be related in a certain events process other than other events manner. For example, for credit sales events, this will obviously precede the cash collection on account event. After identifying the events and the related resource and engine entities, the final stop is to identify the cardinality and optionality of each relationship. Well, this is business process. Next, let's see how to deal with the information process. Again, here we use DFD model, data flow diagrams. And again, this DFD process modeling is aimed at understanding the flows of data and the processes that modify data. There are three types of information process models using DFD. They are recording process, maintenance process, and reporting process. Recording, maintenance, and recording. Recording process DFD are needed for all events on the ER diagram. Maintenance DFD are needed for each engine and resources entities on the ER diagram, and the reporting process are needed for every single entity. The reporting process DFDs are needed for every single entities on the ER diagram. Okay, first of all, let's see DFD process in detail. DFD process, the recording processing DFD. This is needed to record all aspects of each business event identified in the ER diagram. If you can recall that the model integration step involves making explicit links between logical data models and logical process models. In effect, the events on the logical data model map to processes on the recording process DFD. The business events results in the creation of new information, while the recording process is used to actually record the information resulting from the business events. If there are multiple business events in the EER diagram, a single DFD can often depict the recording process for all events. It is also possible to construct a separate DFD for the recording process associated with each individual event. So here are some rules for constructing recording process DFD. 1. Each event entity on the ER diagram will have a level 0 DFD process. 2. The engines associated with each event should be shown as external entity or engine symbols, providing inputs to or getting outputs from the event process. 3. All resources and engine entities associated with the event entity should be shown as data store, being accessed and or updated by the event process. And 4. A data store should be shown for the event itself, with an arrow going to the data store, indicating that it is being added to. Well, for events related to each other, the processing events data store should be shown as being accessed by the subsequent event process. So for events that are shown as being connected through the data store for the prior event, for two related events, event 1 and event 2, the data store for event 1 is added to by the event 1 process, and event 1 data store is accessed by the event 2 process. Next, let me discuss maintenance process DFD. A maintenance process DFD, it is needed for each resource and engine entity on the ER diagram. Well, essentially, information about resource and engines needs to be maintained in the information system. There are three types of maintenance process. They are add, update, and delete. Add, update, and delete. Well, consider the case of maintenance process for a common resource in business setting. Let's take inventory as example. Inventory items can be added, deleted, or updated. By saying added, it means a new product comes to your inventory stock. By saying it can be deleted, I mean a product that is discontinued. Or updated by saying inventory items, information about inventory items are updated. I mean the change of description or price of an existing product. Well, so now it is a little bit confusing between add and update or delete and update. Well, let's say, for example, if an item in your store is being sold, so what kind of maintenance process DFD do you use? Do you use delete or update. Actually, when an item is being sold, we do not use delete. Instead, we use update. We just update the 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 quantity remains in stock. We -1 or -2, depending on the quantities that you sell. Well, when do we use delete or add? We use add when a new type of inventory is added in your inventory stock, while we use delete when this type of product is no longer sold in your store. This is the distinction. Now, you can easily imagine similar maintenance process for another example is employees. We can also use add, delete, and update. You will inevitably have a series of maintenance process DFDs that are not linked to one each other. In contrast, all process in a recording process DFD for an event will be linked through data store access. The construction of maintenance process DFD is relatively straightforward. For an engine maintenance process, the engine will be shown as an external event or entity, and an engine data store will be shown as a double-headed arrow. If events other than the primary engines are responsible for adding, deleting, or changing information, then they will be also depicted in the DFD diagram. So there will be one process, one data store, and one or more engines who provides the add, delete, update information. For resource maintenance process, engines responsible for maintaining the resource information must be shown, and the resource data store will be shown with a double-headed arrow, indicating that it is being both accessed and updated. So this is maintenance process. And lastly, reporting process. Depending on a number of reports to be generated, one or more reporting processes in Dfds will be needed for each event, resource, and engine on the EER diagram. By reporting process, I mean, well, it simply means the extraction of information from one or more data stores to generate either routine or non-routine reports. In REA terminology, the process of periodically generating reports that summarize the results of ongoing business events is referred to conclusion materialization. In a sense, reports comprise conclusions about the results of business activities. Well, some examples of routine reports include sales analysis report or the payroll reports or like the outstanding purchase orders, etc. A key design decision for an event-oriented database system is whether summarized data representing the results of event activities should be stored in a table or regenerated on the fly whenever the report is requested by a user. For example, a customer's outstanding balance represents the sum of all credit sales for that customer, less the sum of all collections received from that customer. So the customer's balance could either be stored in the customer table or regenerated whenever it is needed by summing all sales for that customer and subtracting sum of all collections from that customer. All right, now that we have introduced business process and information process, now next, let me introduce this nine-step process. This is this is a guide to lead you to construct a information system that can be used in the real world. Okay, now let's specify a detailed process of developing an ER model and related set of DFDs. The first step, the second step, and the third step is definitely to identify the REAs, resource, events, and engines. So let's see them one by one. The first step is to identify the significant events. Business processes such as credit sales, collections from customers, returns and allowance, etc., etc. These are the typical events that you would expect to identify in a business-oriented scenario. But there could be other significant events, such as salesperson calling to customers. Well, these such events is considered non-economic, but in our information system, these events should also be recorded. Well, identified events should be drawn using the entity symbol. That is a rectangle. And event entities should be drawn sequentially from top to bottom, with the earliest event at the top and the last event at the bottom. The second step, to identify the resources. Second step. Well, this is actually a step for the question like the what is being used or obtained. For each event identified in the first step, identify any resources that are used by, created by, or otherwise involved in the event. Resources typically have an access connotation, such as finished goods inventory, cash, raw material, etc. There could be multiple resources associated with a single event. As each related resource is identified, it is useful to construct a label that is descriptive of the relationship between the resource and event. This label should be used for the relationship symbol between the resource and the event in the DER diagram. But resources are drawn to the left of the events using the entity symbol with a diamond connecting a resource to all events entities to which it has some relationship. Step 3 is definitely to identify the events. Well, this step is actually for the questions like the who is involved. Engines could be within the organization or outside the organization. Some examples of internal engines are like the salespersons, clerks, technicians, and managers. Some examples of external engines are like the vendors, the customers, the provider of services, etc. etc. Well, economic events usually have both internal and external engines associated with each other. As each related engine is identified, it is useful to come up with a label that is descriptive of the relationship between the engines and the events. This label should be used for the relationship symbol between the engines and the events in the ER diagram. And lastly, engines are drawn to the right of events using the entity symbol with a diamond connecting an engine to all events entities with which engine has some relationship. Step 4 is to identify relationships. Resources and engines are typically related to one another through a significant event. Additionally, as the duality concept suggests, resources are both increased and decreased through events, which suggests a pattern of relationship. It is possible that two resources or two engines have a direct relationship not stemming from any event. So it is necessary to identify resources related to one another, as well as the engines related to one another. Finally, it is also necessary to identify the interrelationships between events. Well, the next step, step 5. Step 5 is to specify optionality and cardinality of relationships. Well, for each relationship identified in step 2, step 3, or step 4, it is necessary to identify whether the relationship is optional or mandatory, and also the cardinality of relationship. That is, we learned about 3 types of cardinality: one to one, one to many, and many to many. While the narrative description may not necessarily provide the details of optionality and cardinality of relationships, it is nevertheless useful to make some logical assumptions about these aspects of relationships. Of course, in the real world setting, the users would be interviewed for clarification regarding to relationships that are ambiguous in terms of optionality and cardinality. Step 6 is to identify the attributes of events, resource, and engines. The attributes. Well, unlike the basic ER diagram, the ER diagram that was introduced in the last class also show the attributes for each event, resource, and engines. It is necessary to identify the attributes. In a sense, the question being asked for each event, resource, and engine is like the what is it about this event or resource or engine that we want to know about. For example, the attributes of interest for a sales event would definitely include like the date of sale, the customer to whom the items are being sold, which items are being sold, or like the which items are included in this sales order, and in what quantity, etc., etc. These questions, the attributes regarding to resource, events, or engines. So for engines, like a customer, the attributes may probably include the name, the address, phone number, outstanding balance, credit limits, etc., etc. So this step is just to identify some useful and possible attributes. Step 7. is to identify the information process. Well, as indicated earlier, information processes are modeled using DFD for each of the three types of information process: recording, maintaining, and reporting. Each event entity will require a recording process. The recording process captures all relevant information about the event. Each resource and agent event, each resource and agent entity will require a maintenance process to add, update, and delete information about the resource or entity. For example, a maintenance process will be needed to add information about new employees or to update information about existing employees or to delete employee information for those who leave the organization. And finally, we need the reporting process. One or more reporting process must be created for every report to be generated. So this is step 7, to identify the information process. The last two steps, step 8, design the structure of data repository, and step 9, to implement the design. These actually are 2 steps involved in the next chapter. That is physical design for database system. So I will discuss these 2 steps in detail in the last chapter, in the next chapter, which is also the last chapter of this class. So I think that's the end of this class. But before you leave, I'm gonna show something related to the next class. Well, in the next class, I'm gonna use an example to demonstrate the application of this 9-step process. So I'm gonna leave this narrative description on the screen for you, so that before the next class, you're required to read this narrative. So for those who are watching the recording of this class, I think you need to pause the class and read it. So here it is, this narrative. This is actually a student's registration process. So based on this narrative description, we will use this 9-step process guide to build a simple information system. Well, this is the narrative left for you to read through, and also a little bit hint. So this slide is the developed REA model. for this information process. All right, this is the end of this class. And as I said, in the next class, we will use this example to build a information system. Well, actually, in the future, as I said, you guys may be information system designers. So your future job is very similar to this one. You will be given a narrative. Most likely, you get this narrative or get some information from your users. And according to their needs, your job is to design an information system. So I will leave this narrative description on the last screen. So before you leave, please let me know if you have any questions. No more questions? All right. So please remember to read this through this narrative description. And in the next class, again, I will use this 9-step process guide to lead you to build an information system. Okay, this is the end of this class. I will see you this Wednesday morning. Bye bye.